Rob, I'm always fascinated by the cat and mouse game that goes through, attackers and defenders. Talk to us about this case in Nevada where essentially administrators downloaded some sort of tainted program that, essentially allowed the attackers inside a system.
Probably most interesting was the fact that it used what's called malvertising to trick an administrator within the organization to download a tainted version of software. So they specifically targeted a tool that a system administrator is likely to use or to download.
All the signs were there to point that this was correct what the person was doing.
From the user's perspective, they went into Google, they searched for the tool that they wanted. Unfortunately, anybody can pay for sponsored results within Google, and obviously the threat actors had paid for a sponsored result. So instead of going to the down here link, they went to the up there link, which happened to be one that was paid for by the bad actors.
Our traditional sort of antivirus tools that have a database of known bad software didn't have this in their system until like 2.5 months later. Pretty much this software was working great for over 2 months.
To be perfectly honest, it wouldn't have mattered if it picked it up 2 days after it was picked up on the system or 2 hours after it was picked up on the system, because what that malware-laced version of the software did was it opened persistent command and control communications to the attackers. Once that command and control is established, once that persistence is established, the attacker has access to that environment.
Your traditional method is deny by default. If we have not approved the software, let's deny it. But there's an out where, administrator goes, oh, no, but I want to really run this piece of software. And still there's a defense mechanism against that. Explain.
Correct. So we have this concept of what we call built-in applications. So built-in or ThreatLocker managed applications are application definitions that we manage. Now, the reason we do it is for convenience of our customers, because we don't want them to have to react or respond every time a new version of a piece of software comes out. But one of the great things about those built-in applications is that if you download a malware-laced version of Acrobat or Putty or whatever the tool happens to be, that will not match our built-in, because it might have aspects to it. It might look the same, it might have the same logo, but it's not fundamentally the same file as the ones that we will have cataloged. So what that means is it's a huge red flag. You're trying to run this tool, it doesn't match ThreatLocker's built-in. It's something that you should be extremely careful about.
I think it's very interesting you have those two levels of protection. You have the standard deny by default, but then you give people the out of like, oh, but in this situation, I want to run it. And you sort of can start to open that door, but you still check at that point.
We do also offer a testing environment, which is basically a VDI, a transient VDI that administrators can spin up and run.
You can let them play in a sandbox.
You can let them run in a sandbox. Now, the cool thing about that is everything that you run through that sandbox is matched against VirusTotal. So it's not just checking one AV, it's checking 40 or 50 different AVs to see if any of them think that the thing might be in any way dodgy.
There's multiple levels here.
Yeah, default deny is absolutely the thing that will keep you safe in a circumstance like this. But again, it's about also giving them tools to make decisions to say, well, look, okay, I'm not sure about this, but let me run it through a testing environment and see if it matches against VirusTotal, see what it does, see if it behaves okay. Does it made, I mean, another interesting thing is it actually made, in the case of Nevada, that persistence is something that would have been, or the persistence that was established is something that would have shown up pretty much immediately in the testing environment, because one of the things we check for in the testing environment, as well as matching against all those different antiviruses, is to say, well, look, are changes made to the system? And if they are, what they are. So you've got complete visibility over what this thing is doing, this malware-laced version of this legitimate tool is doing. So again, there's going to be basically red flags or red lights going off all over the place, going, you really should think twice about allowing this to run on any machines.
Thank you so much, Rob. And to our audience, if you want the level of protection that will help those antivirus programs just can't give you at this current time, go check out what they're doing over there at ThreatLocker. There's a web address right there, threatlocker.com. Add the /CISO at the end. It's a good way to let them know that ThreatLocker, that you heard about them through the CISO series. threatlocker.com/CISO.